Transparent HTTP proxy. In some cases, you might want to block users to access a specific website. But unfortunately, that website is consisted of a collection of hosts with multiple IP addresses. You have no idea on how to catch all the IP addresses and put those IP addresses on the block list. In this case, you need application layer logic and you have to combine several modules to do this task. The operation principle is quite easy. Redirect all the outgoing HTTP traffic to HTTP proxy and do the access control on HTTP proxy. Currently, HTTP proxy configuration menus can be found under border proxy. If HTTP proxy is listening in the port 3128, you can use the following procedures to block a website: from border rule add rule, set action, redirect source, LOC destination, 3128 protocol, TCP destination port, 80 source port, original destination IP, 172.16.9.1, assume 172.16.9.1 is the IP address of ETH1, you do not want to block your access to the firewall via web browser. And from border proxy web caching, turn on transparent proxy. Do not forget to set the network that is allowed to access this proxy. For those IP addresses not being listed in the network list, they are not allowed to use this HTTP proxy. And in border proxy URL screening, you can add the domain names you would like to block so that users will not be able to access those web pages. This approach is applicable to other network application in addition to HTTP as long as the proxy servers exist for those applications. It also can block file uploading via HTML's form. However, packets in HTTPS are encrypted so that the packets cannot be inspected in midway. Thus, the file uploading in HTTPS cannot be detected. If you want to block this type of actions completely, you should block HTTPS at first. Web access time control via proxy. We can use proxy to block web access from LAN to internet for a specified time frame. This can be achieved via the usage border proxy access block time. For example, we would like to block the internet access, web access via HTTP, from 8 to 12 o'clock on Monday. We can have the following setting: weekday, Monday, time, HHMM 8 to 12 o'clock, and press submit button. Do not forget to check the box perform web access time frame checking after you settle all the time frame setting. And you can specify the time frame one by one by adding them into the blocked list. This regulates the time frame for internet web access. Of course, it is necessary to force everybody to use proxy by blocking all the traffic with internet destination TCP port 80 at first in the border control rule. Rate limit control. How to set the limit of connection rate for a TCP/UDP port? It can be done via border rule add rule. To protect the application on the machine is overloaded by unexpected large volume of network request, it would be better to consider about the connection limit. The firewall allows setting the number of new connections in the sense of average and burst rate. The average means the system will take the average since it is running and check if the current average is over the limit. If it is over the limit, it will reject the new connection. For burst rate, it just regulates the upper limit in any instant. Please notice that the limit set here is for new connections. For the connection already established, it will not drop. So, if a connection is there for quite a long time, it might block the newcomers to use the service. DMZ, demilitary zone, of firewall. What is DMZ used for? In our default setting, hosts in DMZ can access internet, but they cannot access the hosts in the local area network, labeled as LOC. We start with the review on how we partition the network region to apply the rules in the firewall. When only two Ethernet interfaces are present, known as ETH0 and ETH1, we partition the whole network into three regions by labeling them as LOC, FW, and NET. The region NET stands for the network connecting to the interface ETH0, the region LOC stands for the network connecting to the region ETH1, and FW stands for the firewall machine itself. By default, we allow any stations in LOC to access the region NET freely. From the region NET to access the servers located in LOC, port forwarding, DNAT, needs to be applied by adding the corresponding rules. After the software release at the date around September 2007, the version number is TED83.ISO before VEDXXX.ISO series, the firewall will automatically be configured for the usage of DMZ when third Ethernet interface ETH2 is present. For the previous releases, it was designed for the usage of two Ethernet interfaces. If the third Ethernet interface ETH2 was present, the region connecting to ETH2 also belonged to LOC. But starting from the release TED83.ISO, the region connecting to ETH2 is labeled as DMZ. The latest release, starting with VED426.ISO, allows defining the Ethernet interfaces at will. We will talk about that later. In previous releases, if ETH2 is present, it still belongs to the region LOC with different subnet address space as the following diagram indicated. It is necessary to use the notation LOC 172.16.9.0/24 or LOC 172.16.10.0/24 to apply additional rules on a specific area in LOC region. So, it can also achieve the similar configuration for DMZ functionalities in this way. In the release of TED83.ISO, DMZ will show up when third Ethernet interface ETH2 is present. Some predefined rules already exist for DMZ by default. Those rules do not have to be added when you use the firewall. Those predefined rules are not shown on the web UI, so that you should always keep in mind about those predefined rules. It is forbidden for those stations inside the region DMZ to access the region LOC. The firewall itself FW cannot be accessed from DMZ unless some additional rules are added into firewall for that action. In our system, DMZ is not completely demilitary by default. You have to use DNAT action in the border rule add rule to forward the traffic into specific host in DMZ. For example, if we want to forward the traffic associated with IP address 1.2.3.4 TCP port 25 to a host located in DMZ with private IP address 172.16.11.12, we will use the following configuration in the following diagram. ETH0:1.2.3.4/255.255.255.0, net, traffic to ETH0 1.2.3.4 TCP port 25 public IP addresses public network firewall, port forwarding, ETH2 172.16.11.12 ETH1 private network DNAT mail server, LOC, 172.16.9.0/24, DMZ, private IP addresses 172.16.11.0/24 addresses VoIP server forbidden. C. How to do port forwarding by forwarding the internet traffic to a host in DMZ. Navigate via border rule add rule. If you only have one IP address 1.2.3.4 binding on ETH0, you can just use action, DNAT source, net destination, DMZ 172.16.11.12 protocol, TCP destination port, 25. If IP aliasing is used by binding multiple IP addresses on ETH0, it is necessary to specify original destination IP explicitly, action, DNAT source, net destination, DMZ 172.16.11.12 protocol, TCP destination port, 25, source port, original destination IP, 1.2.3.4. The hosts in LOC can use 172.16.11.12 to access that machine in DMZ directly. If you prefer the traffic from LOC with destination IP 1.2.3.4 and destination port TCP 25 to be forwarded to 172.16.11.12, you should add the following rule action, DNAT source, LOC destination, DMZ 172.16.11.12 protocol, TCP destination port, 25, source port, original destination IP, 1.2.3.4. ETH0:1.2.3.4/255.255.255.0 net, traffic to ETH0 1.2.3.4 TCP port 25 public IP addresses public network firewall, port forwarding, ETH2 172.16.11.12 ETH1 private network DNAT mail server, LOC, 172.16.9.0/24, DMZ, private IP addresses 172.16.11.0/24 addresses VoIP server 172.16.11.33 forbidden. C. And let's take a look at more examples. If you want to deploy a VoIP server into DMZ, what is the necessary step to do? Assume 1.2.3.5 is the public IP address for this VoIP server known in the public internet and its private IP address is 172.16.11.33. How to do port forwarding to IAX traffic? It also can be done via border rule add rule. If the VoIP server is using IAX protocol, it is sufficient to forward UDP 4569 to the private address of that VoIP server, action, DNAT source, net destination, DMZ 172.16.11.33 protocol, UDP destination port, 4569, source port, original destination IP, 1.2.3.5. How to do port forwarding for SIP traffic? The SIP traffic itself and associated RTP traffic can be forwarded via border rule add rule too. If the VoIP server is using SIP, session initialization protocol, then the situation is a little bit more complicated because it usually comes with stream using RTP, real-time transport protocol. If it is using TCP/UDP 5060 for SIP and UDP ports 10,000 to 20,000 for RTP media stream, we should set action, DNAT source, net destination, DMZ 172.16.11.33 protocol, TCP destination port, 5060, source port, original destination IP, 1.2.3.5. Action, DNAT source, net destination, DMZ 172.16.11.33 protocol, UDP destination port, 5060, source port, original destination IP, 1.2.3.5 for the range of RTP ports. We can use action, DNAT source, net destination, DMZ 172.16.11.33 protocol, UDP destination port, 10,000:20,000 source port, original destination IP, 1.2.3.5. Our philosophy is, you only need to open necessary ports and forward the traffic to the host. No other port should be opened for access to avoid the attack from the crackers. But there is a chance that the communication scheme is quite complicated, that it does not use any fixed TCP or UDP ports, so that you have no way to use traditional rules. In this case, you might just forward all the traffic associated with a specific IP address to that host. For example, action, DNAT source, net destination, DMZ 172.16.11.33 protocol, TCP destination port, source port, original destination IP, 1.2.3.5. The rule above just forwards all the TCP traffic to 172.16.11.33. You can forward all UDP traffic with similar scheme. In general, you should not do this because it just puts the firewall into no use by allowing any traffic to reach that host.